Students, today we're going to look at inequalities. So we need to know how to represent inequalities on a number line, know the difference between inclusive and exclusive inequalities, and be able to represent inequalities on a number line. All right. Start the problem. Spend no more than 10 minutes doing these questions. So just looking at working at negative numbers. Okay, pause your video, and once you're ready to move on to check your answers, resume the video to do so. Here are your answers. For question 1, we have 2 minus 10, which gives us minus 8. Then we have 5 plus minus 4, so that becomes a minus, so it's 5 minus 4 gives us 1. Then here, this becomes a minus as well, so 10 minus 12 is minus 2, and minus here gives us a plus, so 3 plus 2 gives us 5. Then we're multiplying two negatives, so negative times a negative is positive, so we get positive 20. We have negative 25 divided by a positive 5, so that gives us negative 5. Then minus 3 times 6, negative times positive is negative, so we get negative 18. Then we have negative divided by negative gives us positive, and 24 divided by 3 is 8. Alright. It says the temperature on Tuesday is 5 degrees, on Wednesday it is 6 degrees colder. What's the temperature on Wednesday? So we're going towards the negative side of the thermometer when it's getting colder. So if we go from 5 and go count 6 steps back, we end up at minus 1 degrees Celsius. Then the temperature on Sunday is 4 degrees Celsius. The following day drops by 11. What's the temperature on the following day? So we're at 4 degrees and we're counting back 11 towards the negative side as it has dropped, meaning it's got colder. So that was going to be minus 7 degrees Celsius. Then the last question, we have a table with some temperatures. It says Sam says that Edinburgh is the coldest city. Show that he is wrong by listing the temperatures in ascending order. So if we're going to list our temperatures in ascending order, we're going from the smallest, which is going to be minus 12 degrees, then minus 6 Celsius, then minus 5, then 8, then 12, then 19. And so Sam says Edinburgh is the coldest, but 8 degrees Celsius is representing Edinburgh, so it could not have been the coldest temperature. Our inequalities symbols. Okay, so we have in our yellow box, we know read from left to right, so we'll have the greater than, because we're reading from the left, so the bigger number will be on the left to face where the open part of the symbol is. So greater than 102 is greater than 53. Then our less than, because we read from left to right, so the smaller one will be facing the pointy bit of the sign, so 18 is less than 30. Then we have greater than or equal to, so we need all the numbers that are bigger than or equal to 6, right? So 6 is equal to 6, 7 is greater than 6, 8 is greater than 6, 9 is greater than 6, so they're on the side where the open bit is. Alright, and then on this one we have less than or equal to. This symbol here means that, because we're reading from the left, so we want numbers that are less than or equal to 4. These numbers are, so 1 is less than 4, 2 is less than 4, 3 is less than 4, 4 is equal to 4. It said it can either be less than or equal to 4. Of inequality signs, some problems don't have one specific answer. So you could have values that are greater than, say, 4 for an answer, and that takes in 5, 6, 7, 8, 9, 10 until it continues infinitely, depending on the question. So the inequalities will help to give a range of possible answers for a certain scenario. Okay, so when we're using inequalities, you have to give the whole range of answers by using the inequality sign, which best helps with the comparisons. Let us look at set notation for inequalities. So what if we had x is greater than 3? The set notation would be represented as x is such that x is greater than 3. Okay, so that's a set notation. We can also write the possible values for x as a set. Let's use the integers that satisfy the inequality, and integers are just whole numbers, so we're looking for numbers bigger than 3. So 4, 5, 6, 7, we could go on, so we put 3 dots to say continues, and then we close our set bracket. If we had x is less than or equal to 4, then the set notation would be x is such that x is less than or equal to 4, and we're looking for the integers now to write the integers that satisfy the inequality. So we're looking for the number 4 because it says it can be equal to 4, and also it must be less than 4, so 3, 2, 1, and it could continue forever. So we just close our set. So we have written the integers which would satisfy the values in the inequality. Now I'd like you to write the set notations for these inequalities. And then I would like for you to write the integers that satisfy the inequality. Spend no more than 6 minutes doing these. So you pause the video and then resume when you're ready to check your answer. So here are the answers. We have x is such that x is greater than 5, and then we'll have our integer list to be 6, 7, 8, 9, and could continue forever. The other one, x is such that x is less than 6, and the integer set would be 5, 4, 3, 2, and we could continue forever. And the other one, x is such that x is greater than -2, and then we'll do numbers greater than -2 would be -1, 0, 1, 2, 3. We could go on, so we use dots and close the brackets. Then our next question, x is such that x is less than or equal to 9, and the values we're looking for would include 9 because it says or equal to 9, and then numbers less than 9. Then our last one, x is such that x is greater than or equal to -7. So our integer list now would be -7, and numbers bigger than -7, -6, -5, -4. We could continue forever, and that is the solution to the questions given. Let's look at listing integer values that satisfy the inequality. All right, so if we had minus 3 is less than x is less than or equal to 2, then what we do is we can take the inequality in parts. So we could do this part of the inequality and see that minus 3 needs to be smaller than x, or x needs to be bigger than minus 3. So the values of x bigger than minus 3 will be minus 2, minus 1, 0. Let's pause there so we can see how far we need to go. It says on the other side that x is less than or equal to 2. So we can still continue with our integers from 0, 1, and it says equal to 2. So 2 is also a part of that. So the list of values that satisfy or minus 3 less than x less than or equal to 2 would be minus 2, minus 1, 0, 1, and 2. Let's look at another. If we had minus 2 less than or equal to x less than 4. Okay, so take it in parts. X must be bigger than minus 2, so we need minus 2 bigger than or equal to minus 2. So we need minus 2 and then minus 1 and then 0. We can pause there and look at what the other part of the inequality said. It said x must be less than 4. So we go 1, 2, and 3. And so that is our solution for the values or the integers that satisfy the inequality. Okay, now what if they said we had x is greater than 4, and they say what is the smallest possible integer? If x is going to be greater than 4, it means that our first integer that we can have is 5, and then 6, then 7, then 8, and we could continue, but it asks us for what is the smallest possible value. So the smallest possible value where x is bigger than 4 is 5. So the answer to the question is 5. You could have x is less than 6 and they ask you what is the biggest possible integer, and remember integer is whole number, so we want the values of x that are smaller than 6, so it'd be 5, then 4, 3, then 2, and we keep going smaller and smaller. The question asks for the biggest possible answer or value that we can get from this inequality, so the biggest number we can get is 5, so the answer to that is also 5. To try these questions, spend no more than 5 to 8 minutes completing this task. You need to list all the integers that satisfy the inequalities. Once you're ready to mark, resume the video to check the answers. Okay, so for our first one, we have that 6 must be less than x, and then x must be less than or equal to 9. So our values have to be 7, 8, and 9. Okay, so where we have x is bigger than 6, we see that, and also x is smaller than or equal to 9. Our next answers would be where we have x is bigger than or equal to 3, but x must be smaller than or equal to 6. So 3 is included because of the equal there, less than or equal to, then 4, then 5, and 6 is also included as well because it says or equal to 6. The next one here says that x must be smaller than 5 but bigger than 3. So smaller than 5 is 4, bigger than 3 is 4, so 4 is the answer. The next one says x must be smaller than or equal to 7. So 7 is involved and smaller than. But then it needs to be bigger than or equal to 4. So all these numbers are bigger than 4, so 4 or equal to 4. So that's our answer. Then we have x must be smaller than 4 but bigger than minus 2. Smaller than or equal to 4, so 4 is included. And then smaller. But then it must be bigger than minus 2, so we keep going until we get to minus 1. Okay, so those are your answers. We're going to look at representing inequalities on a number line. So if you want to show greater than or less than, let's go for x is less than 1. So we want the numbers that are less than 1. Our numbers less than 1 are 0, minus 1, minus 2, minus 3, etc. And so what we do is our line will go starting at 1. We place a circle there. We do not shade it because we're looking, that's our reference point, 1. But 1 is not included, so the circle stays blank. We do not shade. And then we need to put our arrow in this direction to say that we're going for numbers smaller than 1. Here, if we want to show greater than or equal to or less than or equal to, the same idea. So you will look at an example of x is less than or equal to 1. So again, our numbers less than 1 are 0, minus 1, minus 2, minus 3, minus 4, etc. But it says or equal to 1, so that means 1 is included. So our reference, again, because we are 1, we'll start at 1. We'll put a shaded dot to say 1 is included, and our arrow, of course, will go in that direction towards the numbers that are less than 1. So as a note, whenever it says less than or equal to, you shade the dot, and whenever it says just less than or just greater than, then we draw a circle, we do not shade it. We wanted to represent x is less than 7. 7 is our reference, so we go to 7, and it needs to be less than 7, so 6, 5, 4, 3, 2, 1, going in that direction. So we just draw our arrow going in that direction. We do not shade it because it does not say equal to. We need x to be greater than or equal to minus 2, so our reference is minus 2. So that's where we start, and then we're going to numbers greater than minus 2, so we're going towards the right. So we'll draw a circle above minus 2, and we shade it in because it says or equal to, and then our arrow will go in that direction. Here we have another problem where we have x needs to be bigger than minus 2, but it should also be less than or equal to 7. So our 7 is our reference, and because it said or equal to, we need to shade that one in. And our minus 2 is also another reference, so we have it above minus 2. We do not shade it in because it does not say or equal to on this part. Now it says that the numbers for x must be greater than minus 2, so we'll be going in this direction, and it should also be less than or equal to 7, so going in this direction, so the values are meeting in the middle. Alright, so that is a solution for minus 2 less than x less than or equal to 7, shown on a number line. Another problem where x needs to be less than minus 2, and it should be greater than 5. So our two references, we have 5 and we have minus 2, but x needs to be less than minus 2. So less than minus 2 then is minus 3, minus 4, minus 5. So we're going in this direction. And then x must also be greater than 5. So greater than 5 is 6, 7, 8, 9. So that is our inequality. Okay, notice we didn't shade any of these rings in because it didn't say less than or equal to or greater than or equal to. So that's our solution. For you to do is represent each of the inequalities below on a number line, just like the previous examples. And I would like for you to spend no more than 15 minutes trying these questions. Pause the video and get them done. When you're ready, resume the video to check your answers. Here are your answers. So you'll have a number line and your rings above the relevant numbers, and the arrows going the correct direction, or the lines going the correct in the right places in your drawing. So pause the video and mark, and when you're ready to move on, resume the video. We're going to look at writing inequalities from a number line. So if I had this representation of an inequality and the arrow going in that direction, what would be my inequality? I know 4 is the reference, and then I see that I'm going in the direction that is bigger than 4, so that means that x is bigger than 4 or greater than 4, but because that ring is shaded, it means that 4 is also included, so x is greater than or equal to 4. If I had, say, that representation for an inequality, and I want you to write inequality or reference again. Now it's at minus 4, and we're going in a direction that is less than minus 4, so that means x is less than minus 4. If you notice also, the circle is not shaded in, so it's just less than. If I had this representation for my inequality, and I have one ring shaded, or reference is minus 6 and 2. And notice the values are between minus 6 and 2. So we have from 6 we are going bigger, sorry, from minus 6 we're going bigger than minus 6. So it means that x is bigger than minus 6 or equal to minus 6 as the ring is shaded. But then on this side here we have a ring at 2, and the values from 2 are going in the direction less than 2, so x is less than 2. Okay, and for a final example, let's say we had this here, and then our line between. So our reference is minus 4 and 2, and then we're looking at what our inequality would be. So from minus 4 we're going in this direction, we're going bigger than minus 4, so that means x is bigger than minus 4, and it's not shaded, so cannot put equal to minus 4 there, just less than symbol. And from the 2 we're going in this direction, we're going less than 2, so x must be less than 2. It's not shaded in, so we don't need to add anything to that, just the less than symbol. So now for this activity, I'd like to spend no more than 10 minutes completing it. Pause the video, and once you're ready, resume the video to check your answers. Here are your answers. Please mark to pause the video and do that. Once you're ready to move on, resume the video. To pause the video for 5 minutes and attempt the question. Resume when you're ready to check for the answers. Alright, so it says we have -4 is less than n is less than or equal to 1, where n is an integer, and we need to write down all the possible values of n. So there we go, all the numbers that are bigger than 4, because n need to be bigger than -4, sorry. -3 is bigger than 4, -2, -1, 0, 1 is bigger than 4. We stopped at 1 because it says n needs to be less than or equal to 1. Alright? For part B, it says write down the inequality represented on the number line. So that's our inequality. Our reference is at -2 and 4. -2 is shaded in, so therefore we put less than or equal to. We see the values, of course, are bigger than -2 and less than 4. So that would be the inequality. Right, now we have completed what we need to do today. So send pictures of your work to me and I will give you some feedback. If you have any questions, please send me a message through Show My Homework and I'll respond as quickly as possible. If you are finished before the 100 minutes, I'm gonna add an extension task in the description of the Show My Homework section, so please do those questions if you finish before the 100 minutes. All right, so I look forward to seeing your work. Thank you and have a lovely day.